Hello, everyone. Thank you so much for making it after such a heavy day, and then actually the second day. Thank you so much for coming. I'm very excited to be here. My name is Bognar, and I'm going to talk about something which I've been talking for some time now, but it seems that it always was considered science fiction, that you can interact with content, the eyes alone. And then the reason why I was saying this is considered science fiction, because people said, like, well, you will use your hands, you will use your voice, and not your eyes. Until, of course, Apple introduced its device, and voila, eyes are actually one of the primary interaction mechanics. So before jumping into my presentation, let me tell you about my background. Thank you so much for the intro. Part of me is back in industry. I co-founded 2 startups in 2015 because I said, this is around the corner. I got a full demo from Magic Leap in 2015, and 2016, and I said, well, this is really around the corner, and I think most of us is remembering the jumping whale, right? And then the rest is history. Amazing devices came out, including Magic Leap 1, 2, and of course Apple. But this is the reality. This is very, very hard science to make it work. So these 2 startups which I founded one is Rescan, scanning spaces from a human perspective with a helmet, which is a tiny Google Street View car, if you will, shrunk into a helmet. And Pillantás, which is a Hungarian word for understanding things within a blink of an eye, is to interact with content with the eyes alone. I will come back why I believe that's going to be basically my talk. And then when I realized that there is time, I said, okay, and I've been working enough with PhDs who would say, like, Botond, this doesn't work that way. Science and the humans are different than just like that. I said, okay, there is time for a PhD. So I went back to academia after some time, and I was very lucky to get into UC Berkeley, where I'm doing an interdisciplinary track where I combine architecture, information science, and HCI. That is literally focusing on spatial aspects of human interaction, of course, the technical and information science parts, and HCI, but HCI on the edges, meaning edges of the science, what is possible today, and then what may be possible tomorrow. So let's jump into the talk. I believe that hands-free interaction is a must for XR. And then I would say, why? Why is hands-free so important for XR? I believe that XR, when we are talking about it, it's a new medium. We are carrying a new device on our head, just like we are carrying a new device in our pocket. And this new device didn't take off until the user interface was done. But actually, every new device, every new medium does not work without a new user interface paradigm. You can think of the desktop computer. It had to have the claviature. You can think of, again, the mobile phone, but the mobile phone is, well, it was mobile, it was a phone, but until you were using your hands, 2 hands to type in, and then it remained that kind of limited device. So it became an actual usable multi-purpose device, what it is today, when it was a full flat screen, no buttons, and you use your finger, and it's touch. So I believe that hands-free is going to be the same story for XR. Why? Because in a public situation just like this, I don't believe that people will talk to their device. I don't believe that they are going to hand gesture. I mean, just think of you, how many of you is using your phone? If my talk is boring, it's okay. Go down and then do your stuff, email, whatever, but obviously, imagine the same thing, you're wearing your glasses and you start to talk to it, your hand gesture, no way. I'm in a business meeting and so on and so forth. My favorite test bench is the intercontinental flight, tourist, economy class, middle seat. Why? You're stuck there for 12 hours and you want to carry on with your life, right? 2 strangers seated in front of you, even if somebody's typing too hard and loud, is battering, and then you feel that batter. It's just socially awkward. You want to continue on your digital life. So today you're typing your phone, but okay. But with glasses, it's just not gonna work if there is some minimal basic interaction mechanic. You will not type an essay with your eyes. You will not do everything with your eyes. You will not do your actual work with your eyes alone, but it will be just enough for supplement, basically, and then make it work, make it roll. Just like with the phone. I mean, you might be able to type a little bit of text or scroll between items, and because it's spatial, you want to move it. Well, enterprise is the very first part of this story. Why? Because enterprise is very, very hand user heavy. I mean, just, again, I've been studied before, but the doctors will not take out their bloody hands and then hand gesture. Actually, talking is a no-go. It's as limited as basically a space station when something is really focused. So the workflow cannot be broken. We will not invent new workflows. We will enhance existing workflows. That's what augmentation is about. You're not swapping it. You cannot swap a human story. You cannot swap what we have been using, our hands, 10 fingers, but you will add something onto it. So when you see a content, your eyes, you can move your head very precisely and your eyes, and then when you want to scroll an inventory, or when you want to just move an X-ray in three-dimensional space, yes, you can do that with your eyes alone. And of course, manufacturing. I mean, manufacturing is about handy work, right? I mean, like assembly lines and so on and so forth. So I don't have to sell, I believe, the enterprise story as the first users, but they, indeed, the very first ones. So eye tracking-based 3D interfaces, I would say, is the way ahead. Hands-free interaction, and it actually, when it's really, you have a hands-free interaction, it does feel like magic. So much so that some of our test users started to say, oh, it feels like I have the force. So actually we gave a name, a fantastic name, it was Gravity Gaze. And this actually also fits the enterprise workflow. What do I mean by the gravity gaze and the vergence? And then I will talk about the vergence a little bit more. What you see is that in spatial computing, I don't believe in flying screens, because that's just like the desktop. We will have more interaction mechanics. Actually, we want to even interact with the flying screen. We need to move it sometimes, right? So in that case, you have a Z, or a depth interaction mechanic, or you need to have it. And this is what our technology is based. This is the focus point, the push and the pull of the object. And of course, navigate it in space freely. Our solution is a software. I need to always say that this is not a hardware, it's a software. And it best works when it's implemented or integrated in the firmware. We are not there yet. Our solution is not finalized because we don't have a final partner to integrate it into a headset. So it always sits on the top, as of today, of other headsets OS. And, but therefore, we are platform agnostic. So let's jump into it. I mentioned the vergence. For those who are not into vision science, vergence is, or the vergence point, is the one when you have two invisible beams coming out from let's call it this way, the axis of your eyes. And wherever you look with two eyes, they actually have a so-called focal point. When I look at the corner, it's here. When I look at my finger, when I move it, this vergence point moves. But it turns out that this vergence point is also trainable. So I can look in midair if my eyes is trained a little bit. I can move this point in midair, or if I have a digital object and I look at it, I can move it. Or if I have a drone and that is interacting, is linked to my headset, I can move the drone. Now, and for those who are in vision science, they're like, wait a minute. I mean, aren't the eyes are completely moving around and then they're just jumping all the time? Even when you're looking at someone, your eyes are zigzagging, called saccades, right? Even when you think that you're focusing on something, you're not. Your eyes are moving. In fact, there are microsaccades, even smaller zigzags, which only just research-grade devices can show. That's like tiny little chunks. So this is the vergence point I was talking about. We put our tech on a test bench. And this is the test bench. This is one of my colleagues you see. And we were testing. This is a kilohertz level eye tracker, testing if the eye tracking based solution, that is the depth, can we interact with it? Can we train it? And what we have done, we pulled in people from the street, and in the upper picture you see when our technology is controlling the content. On the lower, you see when somebody's using a mouse instead of. And after some training time, you can see the red is the mouse control profile, and the green is our technology. As you see, it started to shrink, and this nice peak started to emerge. What it means, well, this is where we got so far, because, as I said, it's not finished. We need more training, we need more development, but this is where it is right now. And to actually put some science behind, there is such thing as D prime, and the D prime is slowly climbing up to 3.5 when it is solid, when we can trust it. The red one is the push, and the green, the red one is the pull, and the blue is the pull. And then you could see that it starts to climb up with time. And that's where we said, okay, so it's trainable. I will show what can we do with it. And as you can see, my talk is about head tracking. But I said to myself, let's show the full map. And I have talked about it also before, that these are the eye tracking or eye movement-based key points, like you can blink, dwell, move, but I'm happy to say that there is push and pull as new eye movement mechanics, so that you can, an object, or even again, a flying drone, you can move, push and pull. But if you have a little robotic something, I can also navigate with that. Why I'm so confident about it, because earlier our patent wasn't, we found it, but it takes some time to get it. And this is just an image from it that you can, and I like the guy because his hands is in a pocket. So it's, our patent is a lot longer, of course. But we actually submitted in 2016, took some time to get it. And it shows how you can move things in midair, among other things. And I said to myself, this is fantastic, but again, people said this is science fiction. I mentioned Apple, however, earlier, that they said they're always thinking ahead. And 2 years later, they filed their own in the same idea. That, again, same idea, moving things with the eye and the head alone. They came with a different angle, so our IP covers one section, they covered all the rest basically, so I would say it's two solid pieces, but it's not to compete because they complement each other. We were focusing on the eye, they are more on the sensors. I'm happy to go into details, but that's not the point of the talk. The point of this picture is that maybe Apple is coming out with it at some point. Slowly we are getting our eyes used to using it. And because right now we are just looking for selection. But again, as I said, there is scientific evidence that eye movements are trainable, and you can train them away so that you can move things in midair. So with that, I was promising demo. I'm so sorry that my colleague stuck at CVPR, which is the same time. Some of you might know that it's a huge conference on computer vision. And he's stuck in, so I wanted to give a live demo. So whoever is interested, later on I can do that, but I have some videos for it to share. And what you're going to see is a Vario device where we're interacting with content, again, eyes alone. You will see the very first scene is a VR scene. Here is an asteroid, and this asteroid is, now I'm going to select it and move it around the box. And this is only eyes and head movements included, nothing else. So you can see it's fairly, now this is an MR, or when this is my colleague's apartment there. There you see, again, an asteroid, which you selected. And there is another asteroid in free space. And this is, the point is that the one which is selected is put behind, and you can nudge it. You can move it around so precisely and that's where our tech is, or that's where our IP is, that you can basically interact with it fairly well. And you will see there is one more scene, but I left this video longer because it takes a little bit of time to kind of like sink it in that this is only eyes and head, and not brain waves or anything else. This is as simple as it can get. And all those devices which have at least 30 hertz eye tracker, we are able to do this. And then you can see that I'm gently nudging. So here is a medical use case. A doctor wants to have, the left side is the user, the right side is just another camera angle. When it's green, that's when the person selected it. Currently, it's dwelling at it, but it could be any selection or activation, could be, maybe even the pinch. And then you can see that in this case, the plane is fixed, and then the doctor could move back and forth the plane while in operation, only with the eyes alone. And of course, with the head, can look there, or actually if the two things are aligned with the patient, like some other companies are doing, aligning the 3D scans with the patient's body, even better, is gently can move it back and forth. And then now it's deactivated, but again, the heads are totally possible to move while it's activated as well. So in short, I think this is the full demo. And with that, I'm ready for questions. Thank you very much.
All right. I'll run the mic over to everyone who has a question because we want to pick up the audio for the recording.
Thanks for that. In that video with the asteroid,
yes,
the asteroid was spinning,
yes,
but that wasn't controlled.
That was not.
Yeah.
So but spinning or moving things is possible in a way with our technology. You just have to imagine that you're reaching out with your eyes as if you're reaching out with two fingers, or you're just poking it. So if there is physics built into it, right, I could move this like this way, right? So an object would be, for turning it, you would, as with in real life, you would, if this would be a flying thing, you would and you want to turn it, you would reach out with your hand and do this. So this, you can do the same thing with your eye, looking at and then turning it. There are a couple of questions there.
Yeah. Question about using EMG. Have you looked at muscle movements or interacting blinks and things like that integrated with this type of technology?
I mean, you could. So it's basically pure eye tracking, and many companies are looking into even just using your jaw. I saw some cool things like your tongue, the interaction mechanics, or other muscles. There are actually these glasses, when they are going to sit on your face, they are literally going to record your facial muscle movements as well. I mean, you saw Apple latest thing, they're even putting EMG into the AirPods. Yes, sure, you can. But where we went to is something as simple as possible. Eye trackers only, because all devices, every XR device will have to have, high-grade XR device, will have to have eye trackers in it. And it works with 30 hertz.
Yeah, I was curious about the contribution of head position and how that's contrasted with eye movement, because often head and eyes either integrate together or differentiate separately. How do you control allocation of head movement versus eye movement?
It's a great question, and then I will start with a funny story because I lost a bottle of champagne on that. I said to, again, one of our colleagues, who was a heavy, super nice guy and an amazing scientist, formerly at NASA, and I said, Steve, his name is Steve Ellis, you can move the whole thing only with the eyes. And I said, Botond, trust me, you will need your head as well, because it's very tiring, really just the eye. So in effect, the device also records, obviously. I mean, like these devices now have, depends which one, but definitely Apple and all the high-grade one, gyro and basically IMU, which is enough, in fact with precision, not enough, it's like super precisely can tell your head movement. And then even I mean, in real life, we are coordinating our head and eye movements. We do that automatically.
So you mean that's a gravitational part, like an inclinometer, or what?
Sorry, I didn't hear it.
I'm sorry, you're ruling out the head movements with like a positioning with gravity, an inclinometer, or
No, I mean, if I understand the question correctly, so let's say this would be a digital object, and I want to move it. So my eye starts to move left when I want to move it, but at some point, when it goes out to a convenient field of view for the eye, then the head starts to move automatically.
Okay.
So basically, it's a human factor question that if I want to move it from here to here, I can do that with my eye, but it's very cumbersome. So eventually, when I start to move my eye, my head moves, and I do it there. And actually, on the Apple patent, is the same way
Okay.
integrated the two things, yes.
Thank you.
Here's one more, or I don't know where's next.
So
Yeah,
gonna-
sorry.
Hi.
Oh, hi.
First of all, this is awesome. I love it. I saw that you're doing this, the Vario demo was in Unity, right? And as far as I know, VisionOS does not give access to raw eye tracking data. How are you getting it around Apple's privacy concerns?
So it's a huge question because it goes into the privacy question, right? Are you collecting the user's eye movements? I am on the side of not collecting it at all. We need to use the eye movements for many applications. I would say foveated rendering, just that, right? But it can be done on the device. We cannot access Apple device, so that's why we have no demo with Apple Vision Pro. I mean, like, that's just as simple as that. But right now, Vario, Quest Pro, and so on, there is access to the eye data. What we need is XYZ, Vive, so that's basically accessible with all the other devices.
Hello. Oh, hi.
Hi.
As a designer and a developer, like, is ultimate goal to kind of think about what would be the next interaction in the spatial experience. And I do get that it's human movement and the eye, but there is like a huge controversy feedback for the Apple Vision eye tracking. So like, it easily makes people get tired because like we actually have to put strength and like we have to be cautious about where we're looking. And if we like lose a track of where we're looking, we kind of have to like look a little bit up, a little bit up, a little bit down in order to get the buttons if we like get the hover effects. And so the ultimate goal, like the questions that I have is like, what do you think about the next interaction is going to be only eye and the head movement, or do you think that like we'll still use our hand?
Before I answer that, I have a question. Do you have an Apple Vision Pro and have you used it longer?
Yeah.
Okay. Because typically, when it's only a 30-minute use case, it takes longer than 30 minutes. I still believe that eye is going to be the primary interaction. But to answer your question, this is where we are today. Even Apple, with their acquisition of SMI, which is a fantastic eye science company, this is where we are today, that it doesn't work 100% for everyone. In my case, it took me a few hours that I got the hang of it, that my eyes are involved in this thing. In fact, the hardest was to not do this. Mm-hmm. I still reach out because it's so when I'm in alone, right? So it's hard to say like, okay, I can keep it because there is a camera and sees, it's like we don't work that way. So I just hate to say this is where we are today, that we need to work on it. Even Apple needs to work on it. And then whatever we can say, it's a fantastic technological marvel, but it's a very, very hard science to get it right, especially with so many eyes we have. As many as we are, right? So next I can obviously jump into the brain interfaces and the devices tracking your brain waves, and then you can interact with it. But I would argue that for interaction, and this is just me, mm-hmm. That when we interact, we are physical, we are spatial. So when I'm interacting with you, I'm using my hands. But actually, inadvertently, I even feel, quote unquote, my eyes moving. It's part of my bodily existence. So I think just by thinking about something, and I'm going to keep still and then think about moving it, I don't think it's compatible with the human interaction nature, right? With so I can fantasize about a human computer and then brain combo, but I think it's for accessibility, yes, absolutely yes, when you have no other means. But I think we will want to be bodily in this case.
Gotcha. Thank you.
All right, well, I think that's unfortunately all the time that we have, but let's thank our speaker, Botond, one more time.
Thank you.